What if I told you there's a fuel additive so effective at protecting engines that multiple oil companies tried to bury it, lobby against it, and even convince governments to restrict its use? Not because it was dangerous, but because it worked too well. Cars that should have needed rebuilds at 100,000 miles were sailing past 300,000 with zero internal wear. Dealerships lost money, parts suppliers panicked, and the entire automotive service industry fought back hard. Today, I'm exposing the full story behind this banned wonder compound, why it disappeared from your local gas station, and how you can still legally use modern alternatives that deliver the same legendary protection. And whatever you do, don't skip the section on mixing ratios, because getting that wrong can actually hurt your engine instead of helping it. Let's dive in. Before we go any further, if you want real automotive truth that the industry doesn't advertise, hit that subscribe button right now. This channel exists to arm you with knowledge they don't want you to have. Let's get started. The additive I'm talking about is tetraethyl lead, or TEL. And before you panic, no, I'm not telling you to pour lead into your tank. That's illegal and dangerous. But understanding why it worked so well teaches us exactly what modern engines need to survive past 200,000 miles. TEL was first added to gasoline in 1921 by General Motors chemist Thomas Migley. Here's something most people don't know. Migley actually tested hundreds of different compounds before landing on TEL. Ethanol worked as an anti-knock agent, but it couldn't be patented, and oil companies hated it because it could be made from crops, threatening their monopoly. So despite knowing about safer alternatives, GM and Standard Oil partnered to commercialize TEL instead. They could patent it, control it, and profit from it exclusively. It solved a massive problem called engine knock, a violent rattling that destroyed pistons and valves in early high-compression engines. Just a few drops per gallon raised the octane rating dramatically, allowed engines to run higher compression ratios, and created a microscopic protective coating on valve seats that prevented metal-on-metal grinding. Cars ran smoother, lasted longer, and needed fewer repairs. By the 1970s, nearly every drop of gasoline sold in America contained TEL, but then the problems started showing up. Lead particles were escaping through exhaust pipes and poisoning the air, the soil, and even children's bloodstreams. The health costs were catastrophic. In 1975, the EPA began phasing out leaded gasoline, and by 1996, it was completely banned for on-road use in the United States. Europe followed. The rest of the world eventually caught up. And just like that, the most effective engine protector ever created vanished from the market. Here's where the story gets interesting. When lead disappeared, so did a hidden layer of engine protection. Older engines, especially those built before 1975, started experiencing rapid valve seat recession. Without that lead coating, exhaust valves began grinding directly into soft cast iron seats, causing loss of compression, rough idle, and expensive headwork. Classic car owners panicked, but modern car owners had no idea they'd lost something valuable too. Because while new engines were designed with hardened valve seats to survive unleaded fuel, they also lost the bonus lubrication and anti-knock protection that TEL provided. Suddenly, the industry had to rely on other additives, and not all of them worked as well. That's where the cover-up begins. Oil companies and automakers knew that unleaded fuel was harsher on engines. Internal memos from the 1980s, later revealed in lawsuits, showed engineers were concerned about increased wear rates, especially in high-mileage engines. But instead of admitting the trade-off, they simply adjusted maintenance schedules, recommended shorter oil change intervals, and quietly reformulated fuel packages. The public never heard a word. And here's the kicker. Some aftermarket companies tried to create lead replacement additives that mimicked TEL's protective effects using safer chemicals. And guess what happened? Lobbying groups tied to major oil brands pushed for restrictions, warning labels, and even bans on certain compounds, claiming they were unproven or potentially harmful. But the real reason was money. If engines lasted twice as long, fewer parts would sell, Fewer services would be needed, and dealerships would lose billions in revenue. Think about it. The entire supply chain profits from engine wear. Spark plug manufacturers, piston ring suppliers, head gasket companies, machine shops that resurface heads and bore cylinders. Every component that wears out represents revenue for someone. An additive that cut wear in half would devastate that ecosystem. The data backs this up. A study published in the Society of Automotive Engineers journal found that engines running leaded fuel in controlled tests showed 60% less valve wear after 100,000 simulated miles compared to identical engines on unleaded fuel. Another independent study in the UK showed that classic cars using lead substitute additives experienced virtually zero valve seat recession, even under hard driving. The science was clear. The right additive could extend engine life dramatically. So why isn't everyone using it today? Because most drivers have no idea these alternatives even exist. The marketing machines behind major fuel brands have spent decades convincing you that their fuel is complete, that nothing else is needed, and that aftermarket additives are just snake oil. And while it's true that many gas station additives are overpriced junk, there are a handful of chemically advanced formulas that absolutely work. These modern additives don't use lead. They use compounds like sodium, potassium, or manganese-based organometallics that create similar protective layers without the toxic side effects. And the results in real-world testing are stunning. Let me walk you through exactly how these additives work, why they matter, and which types actually deliver on their promises. First, let's talk about valve seat protection. In any engine, exhaust valves slam shut thousands of times per minute under extreme heat. We're talking temperatures exceeding 1,200 degrees Fahrenheit at the valve face. Each impact creates microscopic wear. The exhaust valve is one of the most punished components in your entire engine. It opens and closes up to 2,500 times per minute at highway speeds, all while being blasted by superheated combustion gases. Over time, the valve seats start to recess, meaning the valves sink deeper into the head, reducing compression and eventually causing misfires and power loss. When this happens, you'll notice symptoms like hard starting when the engine is hot, loss of power under acceleration, and eventually a check engine light for multiple misfires. By the time you notice these symptoms, the damage is already done. Leaded fuel prevented this by depositing a thin layer of lead oxide on the seat, acting like a cushion. Modern lead substitutes use potassium or sodium compounds to achieve the same effect. When burned, they leave behind a hard, heat-resistant layer that protects the seats from wear. Engines using these additives in long-term tests show valve seat wear reduced by up to 50%, even after 150,000 miles of hard use. Second, let's talk octane boost. High-octane fuel resists knocking and pinging, which allows your engine to run its intended timing maps without pulling back spark advance. TL was incredibly effective at this. Just a small amount could boost octane by 10 points or more. Today's replacements like MMT, methylcyclopentadienyl manganese tricarbonyl, can raise octane by 2 to 5 points per tank. That might not sound like much, but for older engines or performance builds, it's the difference between smooth power and destructive detonation. Drivers running these boosters report sharper throttle response, smoother idle, and noticeably quieter engines under load. Third, let's talk carbon control. One surprise benefit of leaded fuel was that it actually helped keep combustion chambers cleaner. Modern unleaded fuels, especially lower quality ones, tend to leave behind carbon deposits on pistons, valves, and spark plugs. Some aftermarket additives now include detergents and combustion modifiers that burn off carbon while protecting metal surfaces. The result is an engine that stays cleaner inside and runs more efficiently for longer. Now here's the part most people get wrong. Not all additives are created equal, and using the wrong one or the wrong amount can cause serious damage. Let me break it down clearly. If you have a modern engine built after 1980 with hardened valve seats and fuel injection, you don't need lead substitutes at all. What you need are high-quality detergent additives and octane stabilizers. Products like Techron, Seafoam, or Redline SI1 are proven to clean injectors, remove carbon, and restore fuel system performance. Use these every 3,000 to 5,000 miles, and your engine will stay sharp. But if you have a classic car, a vintage motorcycle, or any engine built before unleaded fuel became standard, then yes, a lead replacement additive is essential. Brands like ValveMaster, Lucas Lead Substitute, or StarTron make reliable formulas that protect old valve seats without poisoning your catalytic converter or oxygen sensors. The key is dosage. Most products recommend 1 ounce per 10 gallons of fuel. Over-treating won't give you extra protection. It'll just waste money and potentially foul your spark plugs. Under-treating leaves your valves unprotected. Precision matters. Here's a real-world example. A mechanic in Ohio ran a 1968 Chevy C10 with a stock 350 small block for over 200,000 miles using nothing but pump gas and a lead substitute additive. When he finally tore down the engine out of curiosity, the valve seats showed almost no wear. The measurements were incredible. The valve seat recession was less than 0.003 inches, which is essentially within manufacturing tolerance. For context, an engine running unleaded without protection typically shows 0.015 to 0.025 inches of recession at that mileage, enough to cause serious performance issues. Meanwhile, an identical engine in a truck that ran straight unleaded for just 80,000 miles had severe seat recession and needed a full head rebuild. The owner had to have all 8 exhaust seats cut deeper and fitted with hardened inserts, a job that cost over $2,200 in machine work alone. Same engine, same era, completely different results. That's the power of the right additive used consistently. Now let's talk about the myth that these additives are just placebos. Some people claim it's all marketing and that modern fuel is fine on its own. And for most daily drivers with fuel-injected cars, that's partially true. Top-tier certified gasoline, the kind sold at Shell, Chevron, Costco, and a few others, already contains a solid detergent package that keeps injectors and valves clean. But here's what they won't tell you. Even top-tier fuel varies in quality depending on the region, the season, and how long it sat in the underground tank before you pumped it. Fuel degrades. Additives break down. Moisture sneaks in. If you want truly consistent protection, adding your own high-quality booster every few tanks gives you control the fuel companies can't guarantee. And for those running high-mileage engines, turbo engines, or direct injection engines, aftermarket additives aren't optional. They're insurance. GDI engines are notorious for carbon buildup because fuel never touches the intake valves. In a traditional port injection engine, fuel sprays onto the back of the intake valve every time it opens, which has a natural cleaning effect. But in GDI engines, fuel injects directly into the combustion chamber, so the intake valves only see blow-by oil vapor and exhaust gas recirculation. Over time, this bakes into hard carbon deposits that restrict airflow and eventually prevent the valves from sealing properly. An additive with strong detergents can slow that buildup significantly, keeping the engine breathing properly and delaying the need for a $400 to $800 walnut blasting service. Some shops charge even more, especially for V6 and V8 engines where access is difficult. I've seen quotes as high as $2,500 for carbon cleaning on certain BMW and Audi models. I've seen turbocharged Audis and BMWs with over 150,000 miles that still run like new, simply because the owner added a quality fuel system cleaner every oil change. Compare that to neglected examples that start misfiring and losing power by 60,000 miles. The difference isn't the car, it's the maintenance philosophy. One owner treats prevention as an investment. The other treats repairs as inevitable. Guess which one spends less money over the life of the vehicle? Here's another angle most people miss. Some additives improve lubricity, meaning they reduce friction between metal parts in your fuel system. This is especially important for diesel engines, where ultra-low sulfur diesel, or ULSD, removed much of the natural lubrication that older diesel fuel provided. The sulfur content dropped from 500 parts per million down to just 15 parts per million to meet emission standards. That was great for the environment and for diesel particulate filters, but terrible for fuel pump and injector longevity. Injectors in modern diesels operate at pressures above 30,000 psi. Some new common rail systems run at 35,000 to 40,000 psi. At those pressures, even microscopic wear can cause injector failure. Without proper lubrication, they wear out fast, and replacements can cost $2,000 or more. That's just for parts. Add labor, and you're looking at a $3,000 to $4,000 repair bill for a full set of injectors. A diesel-specific additive, like Hot Shot's Secret, Stanodyne, or Power Service, restores that lubricity and can extend injector life by tens of thousands of miles. Truckers and fleet operators have known this for years. It's one reason their engines regularly hit 500,000 miles, while passenger car diesels often struggle past 150,000. So if these additives work so well, why don't manufacturers just include them in the fuel or recommend them in the owner's manual? Simple. There's no profit in it for them. Automakers make money from service departments, extended warranties, and parts sales. If your engine lasts 300,000 miles with minimal maintenance, you're not buying a new car as often, and you're not visiting the dealer for expensive repairs. It's not a conspiracy theory. It's basic economics. Planned obsolescence isn't always about intentionally breaking things. Sometimes it's just about not making them better than they need to be. I want to share a case that perfectly illustrates this. In the early 2000s, a class action lawsuit was filed against several automakers for premature engine sludge in vehicles like the Toyota Camry, Lexus RX, and Volkswagen Passat. Owners reported total engine failure under 100,000 miles due to thick baked-on sludge that blocked oil passages. The automakers initially blamed owners for not following maintenance schedules, but internal documents revealed that the engines were simply prone to sludge under normal driving conditions, especially with extended oil change intervals. The settlement forced free repairs and updated maintenance guidelines. But here's the thing. Drivers who had been using high-quality synthetic oil and fuel system cleaners from day one rarely experienced the problem. The additive users protected themselves before the lawyers even got involved. Let's get practical. I'm going to walk you through exactly which additives to use, when to use them, and how much to use for maximum engine protection without wasting money. For modern gasoline engines, 1996 and newer, use a fuel injector cleaner every 3,000 to 5,000 miles. Chevron Techron Concentrate Plus is one of the most tested and proven products. It's used by dealerships during service and recommended by mechanics nationwide. One bottle treats up to 20 gallons. Add it to a near-empty tank, then fill up. Drive normally. The detergents will clean your injectors, intake valves, and combustion chambers over the next tank. You'll notice smoother idle, crisper throttle, and often a slight bump in fuel economy. For high-mileage engines, over 100,000 miles, consider adding Seafoam motor treatment once every oil change. This product works in both the fuel system and the crankcase. Add 1/3 of the can to your fuel tank, 1/3 to your oil a few hundred miles before your next change, and use the final third as a top engine cleaner by slowly pouring it into a vacuum line while the engine idles. It's old school, but it works. Mechanics have used Seafoam for decades to free stuck lifters, quiet noisy valves, and clean carbon without disassembly. For direct injection engines, especially VW, Audi, BMW, and Hyundai models, use CRC GDI intake valve and turbo cleaner every 10,000 miles. This is a spray cleaner you apply directly into the intake manifold with the engine running. It melts carbon off the valves in real time. Combine this with a good fuel additive, and you can delay or even avoid the need for professional carbon cleaning services. Owners report that engines with over 80,000 miles respond dramatically to this treatment, with restored power and eliminated rough idle. For classic and vintage engines pre-1980, use a lead substitute every single tank. ValveMaster Plus is widely trusted in the classic car community. It contains potassium-based compounds that protect valve seats without harming catalytic converters if your classic has been upgraded with one. Dosage is typically 1 ounce per 10 gallons. Don't skip tanks. Consistency is what builds the protective layer your engine needs. For diesel engines, use a quality additive every fill-up, especially in winter. Diesel fuel can gel in cold weather, clogging filters and killing engines. Products like Power Service Diesel Clean or Stanodyne Performance Formula prevent gelling, boost cetane for easier starts, and add lubricity to protect your injection system. Diesel owners who run these additives year-round report significantly fewer injector problems and smoother, quieter operation. Now let's address the big question. Are there risks? Can additives harm your engine? The short answer is yes, if you use the wrong product or overdo it. Cheap off-brand octane boosters that contain harmful solvents can damage fuel lines, seals, and sensors. Overusing detergent additives can strip protective oil films and cause excess wear. And using lead substitutes in a modern engine with a catalytic converter can poison the cat, leading to a $1,000 plus replacement. The key is to match the product to your engine's needs and follow the instructions exactly. More is not better. Precision is better. Here's another mistake I see constantly. People add multiple additives to the same tank, thinking they'll get compounded benefits. But some chemicals react poorly together, creating sludge, precipitation, or reduced effectiveness. Stick to one additive per tank, unless the manufacturer specifically says their products are compatible, and always add additives to a nearly empty tank before filling up. This ensures proper mixing and prevents concentrated pockets that can foul injectors or sensors. Let me hit you with some cost analysis, because protecting your engine should make financial sense. A quality fuel system cleaner costs about $10 to $15 per bottle and treats one tank. If you use it every 5,000 miles and drive 15,000 miles per year, that's roughly $30 to $45 annually. Some people might think that sounds like a lot, but let's break down what you're actually preventing. Compare that to the cost of replacing clogged injectors, $400 to $200, or cleaning carbon buildup, $300 to $800, or worse, rebuilding an engine damaged by neglect, $3,000 to $6,000. And those are conservative estimates. I've seen engine rebuilds quoted at $8,000 to $10,000 for certain vehicles, especially European makes with complex aluminum engines. The return on investment is massive. For less than the cost of 2 oil changes per year, you're protecting some of the most expensive components in your vehicle. And here's the part that really frustrates me. Walk into any dealership service department and ask about fuel additives. Most will either dismiss them entirely or try to sell you their overpriced branded version at 3 times the cost. They'll tell you it's unnecessary or that your fuel is fine. But talk to the actual technicians in the back, the ones turning wrenches every day, and you'll hear a different story. They'll quietly admit that neglected fuel systems are a gold mine for the service department and that owners who use quality additives tend to have fewer problems. It's not a secret. It's just not advertised. One more thing about the ban itself. While TEL is illegal in pump gas, it's still legal to buy and use in off-road applications, including racing fuel, aviation fuel, and marine engines. Race teams have used leaded fuel for decades because it delivers unmatched performance and protection under extreme conditions. NASCAR, drag racing, and vintage racing series all still use leaded race fuel. Aviation gasoline, 100LL, which stands for 100 octane low lead, is still the standard fuel for piston engine aircraft. Pilots have been lobbying for unleaded alternatives for years, but the transition is slow because engine protection is literally a matter of life and death at 10,000 feet. If it were truly just snake oil or unnecessary, professional engine builders wouldn't touch it. But they do, because chemistry doesn't lie. The protective properties are real, measurable, and repeatable. Engine builders who tear down race engines after every event can see the difference with their own eyes. Valve faces stay cleaner. Piston tops show less detonation damage. Bearing surfaces maintain their original crosshatch pattern longer. The lesson here isn't that you should break the law or try to find leaded fuel. The lesson is that the principle behind it, protecting metal surfaces, boosting octane and reducing wear, is still valid and still achievable with modern legal alternatives. The industry buried the concept, not because it was wrong, but because it was too effective. And now that you understand the science, you can make informed decisions that extend your engine's life far beyond what the manual predicts. If you found this information valuable, If it's already changing how you think about fuel and additives, do me a favor. Hit that like button and drop a comment telling me what kind of car you drive and how many miles are on it. I read every single comment, and I love hearing from owners who are serious about making their vehicles last. And if you haven't subscribed yet, what are you waiting for? This channel is built on information the industry doesn't want going mainstream. Subscribe now so you don't miss the next deep dive. Let me wrap this up with one final real-world example that ties everything together. A friend of mine bought a 2005 Honda Accord with 180,000 miles on it. The engine ran rough, the idle was unstable, and fuel economy was terrible. Most people would have walked away or prepared for expensive repairs. But instead, he invested $50 in a combination treatment, one bottle of Techron, one can of Seafoam, and a compression test to establish a baseline. He ran the additives according to instructions, changed the oil, and replaced the air filter. Within 2 tanks of fuel, the rough idle smoothed out. Throttle response sharpened. Fuel economy jumped by nearly 3 mpg, which over 80,000 miles saved him roughly $800 in fuel costs alone. He drove that car for another 80,000 miles, selling it at $260,000 with the original engine still running strong. Total investment in additives over those miles, less than $200. Value of avoided repairs, easily $3,000 or more. That's the power of understanding what your engine actually needs versus what you're told it needs. Prevention beats repair every single time. The banned additive might be gone, but the science behind it lives on in safer, legal, modern formulas that deliver similar results. You just have to know what to look for and how to use it correctly. And now you do. Thanks for sticking with me all the way to the end. If you're serious about engine longevity, check out the next video where I break down the top 5 oil myths that are shortening your engine's life right now. It's packed with data, real-world tests, and more truth bombs the industry doesn't want you hearing. I'll see you there.